So the effect of drugs in the embalming process. This is a fairly important chapter. Within what we've been studying in this class, this is probably one of the most original chapters with new information that you are going to be responsible for. So chemotherapy is the treatment of disease with chemical agents and drugs. Understand that when looking at chemotherapy in general, by this definition, it is not specific to cancer treatment, which is what you need to take away from this. Its purpose is to alleviate pain. Been looking for this magic bullet. Talks about Dr. Ehrlich here. Obviously, there is not one case that will be just one single medication people are taking. These days, people have entire drawers full of medications, which is problematic because all this introduction of drugs causes physiological, which then make our life miserable as embalmers. Your book referenced antibiotics. There's rarely one antibiotic used in a drug treatment. In cancer, a doctor commonly prescribes a cytotoxic and an antimetabolite, which we're going to talk more shortly. There is no such thing as an ideal or normal case in regards to what we do. I know we use that interchangeably with cases that are less complicated than others, but the fact of the matter is, we're never going to find a person that's not taking some type of medication, whether it be baby aspirin, and even in a more liberal sense, things like multivitamins and things like that. The longer the drug is taken, the more intense the problem. The longer you have been receiving treatment, the more likely it's going to have had some type of physiological change on your body. And besides the negative effects of the drug, there may be chemical reactions between the drug in the tissue and the embalming fluid, which further complicates things. Proteins obviously are very important for us for preservation. Formaldehyde reacts with the protein, so when the protein decomposes or has something else happen to it, that makes our life miserable. They break down quickly even if there was nothing to help it along, and proteins that break down other proteins are called enzymes. Even if a body was completely sterile, we have these things in our system, and the body's basically going to break itself down. We know that is another word called autolysis or autolysis, some people say. And the way that we kind of prevent this from happening is we treat the proteins so they're no longer susceptible to enzymes, and we also change the enzymes so that they can't do their job. Our chemicals do both of these for us. They don't specifically focus on one or the other. And I love giving this embalming math on people. I'm just going to kind of flip here. It takes 470 grams to preserve 10,000, basically 11,000 grams of protein in a 150-pound body. And then it gives you the math for the 30 index fluid. So even for using a 30 index fluid on a normal body, we're looking at almost 3.5 bottles of just arterial solution to meet the formaldehyde demand. So when someone reaches for 2 bottles of 20 index, so that'll be enough, we can see that not even the math kind of adds up. When we start kicking in complicating factors, you can just see that realistically we should be reaching for at least 4 to 6 bottles, even on pretty much normal cases. All chemotherapeutic agents, all medicines are toxic in some way, shape, or form. That's why we have prescriptions so that we moderate their use. Cellular and tissue changes occur when we use a drug. So drug-induced changes may be relatively minor, or they could be major. So that's something like jaundice. Liver is our main detoxification center of the body, and every drug eventually gets into hepatic or liver circulation. The drug can be changed into another form due to enzymes acting on the drug, or the drug may even change the tissues of the liver itself. And whenever the liver starts to function abnormally, jaundice results and we have problems. After the liver, drugs then go to the kidneys, and those that accumulate in other parts of the body must at least pass once through the kidneys for cycling through. And if the drugs cause drastic changes, renal insufficiency follows, which means even more problems. When your kidneys and your liver aren't working, pretty much you're going to be dead meat soon. Generally, it's urea, nitrogenous waste, ammonia, creatinine, and other wastes. They start to build up, and all of this causes problem and plays with our embalming chemicals. They then change the biochemical constituents of the blood and damage blood vessels, clot formation, breakdown of blood. And if we're looking at stuff, we're not just looking at distribution problems, we're looking at discoloration problems. If we have lysis of the blood, that means the heme is separating and leaking into the tissues and causing postmortem stain. Ecchymoses and purpura are some of the most common discolorations as a result of hemolysis. Problems likely to be found with embalming the chemotherapeutic body does not result from the reaction of the preservative with the drug. So what it's basically saying is the drug that you're taking is not going to be the problem that the formaldehyde reacts with. You can see that realistically, it was everything else the drug caused. It says here the drug is metabolized. It's consumed by the body, leaving little, if anything, left. It is always what it does to the body, the kidney failure, the liver failure, the hardening of the arteries, that is our problem. The drug shutting down is more of a causative problem than the formaldehyde reacting with the drug. Us dealing with the quote-unquote complications of the drug is more important than us actually dealing with the drug itself. Neutralization of formaldehyde by ammonia forms hexamethylene. That's one of the first times we've seen that word. It's 90% of the time the problem at hand. Another large one is the change in permeability of cell membranes. Tetracycline, a common antibiotic, calls chelating. That's an important term, forming a shell of metallic ions, which then doesn't let anything into the cell itself. Water, preservative, etc., which you can imagine is fun and exciting for us. Your book states that because the goal of embalming is to inactivate enzymes present, it is essential the preservatives enter the cell. Yeah, mind blown. Duh. Obviously, the more the drugs, the more complex the reactions, the more physiological problems, and the more we need to get paid the big bucks. Corticosteroids, second most commonly used type of drug, corticosteroids. And from the previous chapter, if you were paying attention, you would remember that this was big when playing with moisture, I believe it was. It's an anti-inflammatory used in arthritic and rheumatic conditions. They're also used in cancer treatment, and it works by suppressing your immunological response. Well, Professor Finn, does that mean viruses and bacteria and whatnot will then have even more leeway to play with our bodies? Why, yes, that's exactly what that means. So despite the problems these things cause, they're also going to let the critters start taking over, which makes our life even more miserable when we're looking at stuff like, fungal infections, the lungs and whatnot. Corticosteroids decrease the permeability of the cell membrane. That is very important. It decreases the ability of the cell to let things in and out. Chronic use results in gastrointestinal ulcers, perforations of the gut that can develop an ulcerative colitis and dehydration. If you've paid attention in path class, you'll know that ulcerative colitis is one of the nastiest diseases in the world. They protect the enzymes of the body, render them difficult to stop, so that means they're going to decompose quick. Oral contraceptives can cause similar effects. Progesterone and derivatives are similar to cortisone. Cortisone can also cause hidden hazards in the body. Your book refers to tuberculosis. It kind of slows it down, but it does not kill it. It then spreads throughout the entire body, and everything then becomes contagious. Use of surfactants is recommended to restore permeability of the cells, so that would be a co-injection you'd probably want to use, along with the stronger than average fluid, probably higher than 2%, if not higher index, so that you can go ahead and get something done. So with cancer, we saw earlier that there were two main categories, cytotoxic and antimetabolite. Know the differences. And when it mentions something that falls into a category like nitrogen mustards, alkylating agents, understand it. That's important. Okay, that's very, very important. Cachexia, we've seen this term used. I've used it in other lectures. Severe wasting away, emaciation times 10, okay, is usually present to antimetabolite use because of the fact that your body cannot actually function. The cells have trouble actually reproducing, and obviously this causes problems for you. Radiation obviously causes additional problems. When it comes to radiation, generally when we get the call to remove a body, the body is safe for removal. That being said, it is important that you know that you do not embalm a body unless it's certified as safe by a radiation safety officer. And generally, these are the bodies that you're picking up right from the cancer center that pass away there. Main isotopes, and you need to know all of these. You need to know all of these. Note card them, whatever it takes. Cobalt, iodine, phosphorus, radium, gold, strontium. Professor Finn, what about the numbers? The numbers matter too. The numbers matter too. Okay? Beta rays are stopped much more easily than gamma rays. Gamma rays require shielding similar to that of an X-ray. You might have remembered this from the old 1980s TV serial, The Incredible Hulk, Bruce Bixby and Lou Ferrigno. Back in the day, believe it or not, this thing still exists. It doesn't have really anything to do with radiation. It's a microscope. It's actually a microscope. I believe it's somewhere here in Florida, one of the universities too. We measure radioactive activity in millicurie. Know the abbreviation, small n, capital C, small I. And that is the amount of radioactive material in which 37 atoms disintegrate each second. Medical institutions must tag, okay, warning of radioisotope use. They cannot release a body unless it drops below. And this is important. 30 millicurie for unautopsied bodies and 5 millicurie for autopsies. Follow every instruction you are given by a cancer treatment facility if a body has been irradiated. Standard procedure used for bodies underneath the acceptable levels, 30 and 5. Anything over, you better pay attention to what they're saying. Although realistically, we're probably never going to get called into embalm for a person that's quote-unquote proverbially glowing in the dark. Recommended precautions, protection, time of exposure, and distance. Wear the right stuff. Do not be there longer than you have to, and keep far away of anything. And it talks more about this. Wear rubber gloves, 2 pairs if possible. Heavy rubber in standard PPEs. So if you think it's already uncomfortable in the Tyvek suit, you're about to one-up it. Work in pairs if you can. Have instruments ready. Have your fluids pre-mixed. And avoid raising vessels where they have put the radioactive pellet. Every 3 feet is the magic number. For every 3 feet you walk away, exposures reduce considerably. We're not actually performing embalming. Get away from it. Just stand away from the body and have a constant flow of water underneath the body to take anything that might be irradiated and flush it right down. If you grow a 20-foot gator in the sewer, that's your problem. Body bridges cover as much of the area as possible with sheeting that can be disposed of later. Gloves should be washed frequently to get stuff off of you. Forceps and sponge or sheeting to clean up spills. Get it done. Flush instruments with running water. Soak in soap and water. Rinse it again. As much as you can that you can throw stuff away, use disposable items, disposable scalpels, etc. Anything that has been irradiated should be kept for a suitable amount of time to ensure the half-life is done. And the radiation officer will tell you these things. If you get any material from that body into an open wound on you, which you should not do, ever, you should need to flush it and then consult the radiation officer about what you should do. And then listen to anything else. You may have to delay cavity injection if you're one of those that likes to do it immediately, or it falls in the category where you want to do it like congestive heart failure or something like that, where you're supposed to aspirate immediately after. Radiation doesn't affect preservation, so you can use your standards. Just because they're undergoing radiation treatment does not mean you reach for the 30-plus index every single time. Tranks generally result in weight loss because you're too bloody happy. Due to a lack of protein, complications then occur, not enough firming, etc. Your book says a person on a trip does not care about nutrition. That's pretty much true. If you've been smoking the reefer, you know that your diet consists of Taco Bell and Doritos. Hardly either of those are good for your system. Mood-altering drugs. You have 5 types of mood-altering drugs: sedatives, stims, tranks, narcotics, antidepressants. And he gives you descriptions or names, at least, of each of these things. Yes, you do have to know what they are. So if I say barbiturate, classify it, you should not just be able to tell me it's a mood-altering drug. You should be able to tell me it's a sedative versus a narcotic. So that would be important. Long-term use of most of these results in jaundice problems because it's destroying your liver, destroying your blood, etc. Diabetes, tolbutamide, chloropropamide are 2 common diabetes drugs. Both of them kill your liver, go figure. Continuous use of oral diabetic drugs causes circulatory disorders. Acidosis occurs, basically cramping, unless you use some type of water corrective, clot reduce, some type of buffer. You're essentially speeding up. In this slide, what it's saying is basically speeding up rigor. It's pretty crazy. They can cause embalming complications. They're really not as severe as other drugs. Yeah, it might cause some jaundice, but realistically, it's, it is what it is. No drug, no matter how often, how long, or in what concentration is used, could ever be administered long enough to react significantly with our embalming fluid. Again, It's not talking about the physiological change it causes on the body. That is something different. This is strictly saying that you simply cannot consume enough of a drug to actually have the drug cause problems with your injection solution. It's always a physiological reaction, not the drug itself. So it talks over here about different types of fun and common problems associated. Yes, you should probably know that. Once in the bloodstream, the drug is rapidly diluted. Go figure. 58% of the body weight in water is 100, which is quite interesting considering it was 55%, right, in the previous chapter. Now we have 58%. So I'm just going to say in the chapter that talks about moisture, go with that one. This is strictly something for informational purposes that gives you an idea that half of us is basically body weight. That's basically 41 liters, including blood in the average 150-pound body. You're taking like 500 milligrams of a pill. It ain't going to do nothing. Business is normal, okay? Perform an embalming analysis. Treat each individual case as unique. This should not be something new that you're hearing for the first time. And everything just goes by what you see. Thanks for your attention. We'll move on to the next one.